Hi everyone, welcome to another new session of AI agents, where I'm going to be discussing about intelligent customer query router agent. Now imagine you are building a customer support system for an online education platform. Users message you about everything, buffering videos, which course to take next, a payment that didn't go through, or just a vague, I have a problem. If you send every single one of these to one general purpose AI agent, it is going to struggle. But in this video, I'm going to show you how I built an intelligent query router agent using LangGraph and LangChange, an AI system that reads the user's query and decides which department should handle it and routes it all automatically. But with a confidence-based safety net. So uncertain queries never go to the wrong specialist. So let's get started. Now, if you see over here, this is a router agent. A router agent doesn't solve user's problem itself. Its job is to answer one question. Where should this request go? So, this is a router agent, not a Q&A agent. Its only job is where should this request go? Not a fully solved problem means not a fully solve the problem itself. It has to decide where is to route the request. Now, there are four destinations over here. Four destinations over here means drives a conditional edge in a lang graph with dispatch a query. Four specialist departments, or you can say four specialist departments. Okay. Now, this is a technical support, course recommendations, payments, and billing. So if there is issue related to video player issues like buffering, okay, or login problems or website errors, then request should go over here. Okay. The request should go to the technical support or issues with learning paths, prerequisites, which course should I take, then request should go over here or dedicated payments, duplicate charges, invoices, then payment and billing or something ambiguous like, I want to contact to customer support then this over here. Moreover, I've used LangGraph for orchestration, for orchestration. Okay. Then I've also used LangChain plus OpenAI, okay, for LLM calls. Okay. Then I have used Pydantic for structured output and Langsmith for tracing. For tracing everything, input, output, or what happens behind the scenes. I do not want the black box system because I can't see anything. I want to see what is happening under the hood. Okay. Okay. Now let's understand this architectural diagram. Now, user query to start. Suppose user enters the graph as a human message. Okay. Then this router node combines the query, user query with the system prompt. That defines the four categories and their rules, the four categories that we discussed above. Okay. Then it send it to a structured output LLM where router decision, this router decision is a pedantic model with two fields. One is root and another is confidence. Okay. Root is those four roots. Okay. The four technical recommendation, payment, and general. Okay. And confidence is the score. Confidence is the score. Okay. Confidence is the score. So if the LLM's confidence is below 70%, then app overrides the route to general. Okay. LLM, suppose, for example, LLM says maybe technical. And for it, I'll show you the example also for it. Maybe technical. But the application's confidence says it's too low. That is, suppose it is 40, 40% less than 70. Then it will straight away go to the general. It means the app, the app makes the final call. Okay, app makes the final call. Then there is this, what do you call? Conditional edge. Conditional edge. So what it does, it reads the state route. It reads the state route and returns the name of the LangGraph node. Okay, to execute technical agent, the course agent, billing agent, or the general agent. Okay, now if you see, then we have four specialist nodes. Okay, now each of them is just a Python function with its own system prompt, which I'll show you, specialized for that department. Okay, so if there is a technical support problem, go to this one. Course advisory goes this one. Payment billing goes to this one. Then this one. Okay, and each appends an AI message back into the shared state. Okay, then all of these four, this, and this, converges over here. Okay, and then the Langsmith tracing, where every router decision and every specialist response gets logged as a run. So one can inspect exactly what happened after the facts. Okay, now let's get into codes and try to understand few things over here. Ah, okay. Okay. So here, I've installed some of the important packages. Okay, LangChain, LangGraph, LangChain OpenAI, Langsmith, Python dot Python.env. Okay, this is for like loading the secrets from the env file. Okay, instead of hard coding them. Okay, then there are some important libraries like literal, which I'll show you. Then we have Pydantic base model for structured output model or data validation. Okay, and then we have these human message, the user query, AI response, or the system prompt. Okay, and then this is related to the LangGraph that we're going to build. So let's scroll down a bit and try to show you some of the important facts. Now here temperature is equal to 0. Now, what do you mean by temperature is equal to 0? This means the model is consistent instead of being creative. Okay. I want a consistent one. I don't want the model should create its own answer coming from somewhere else. I want it exact what I'm asking for. Okay. Not creative answers. Okay. Then this one I've just tested the connection and the LLM was successful. Okay. Then if you scroll down a bit, this was the literal I was talking about. So every single routing decision has to come back in exactly this shape. Okay. So a route, that's one of my four categories. Okay. This is one of my four categories and a confidence score, right? Then if you scroll down a bit, now this particular line turns a normal chat model into a model that's supposed to output a valid root decision objects. Okay, root decisions objects. Then, okay, this was the test I conducted that my payment was deducted, but my course has not been activated. So what it did, it went to the root billing. That's it called billing agent. That request goes to the billing. Why? Because the confidence score was zero point 0.9. So this sure shot understood that, yeah, that I need to call this one because payment was deducted, but course was not being activated. So it went over there. Okay. Then if we go down over here, this one, system prompt. Now read this particular part. You're an intelligent query routing assistant for an online education platform. Your job is to analyze users' query and route it to the most appropriate specialist department. Okay. Now this is a system prompt. Then there are four numbered routes. Okay. Each with a bullet list of its example types. For example, if I need to call technical, then if the issue is with buffering, video not loading, application errors or login issues, then use this route for technical problems. This particular route for technical problems. Then, if there is related to recommendation, learning path, which course to start, then this route, use this route. Okay, for question related to this. Then, if there is a issue related to billing, then use this billing route. Or if there are general queries, okay, like the request does not clearly belong to technical course or billing or general help, like as I said before, I need to contact the customer care. Then use this route. Then in the end, there are some confidence guidelines. Okay, that is four numeric bands. Okay, each tied to how clearly the query matches the single category. Okay, then after that, I ran a batch of queries. Okay, this one I've already showed you. Go through this one. Okay, the video player keeps buffering. I want to learn generative AI. Which course should I start? The payment was deducted, but my course has not been activated. I need help, but I'm not sure which department should I contact. So four different queries. Okay, let's see what happened. Video player keeps buffering. So the request went to the technical route. Confidence was 0.95. Okay, I want to learn Gen AI. Which course should I start? It went over here to course. Confidence was 0.95. Then payment was deducted, but my course was not being activated. So I think the output got cut. Anyways, let's see this one. My course is not working properly. So it went to the technical. Now, this is what I wanted to show you. If there is an ambiguous query, okay, I have a problem. So think about it, where it's going to go. I don't think so. It's going to go to technical because this is not a technical issue or payment issue, nowhere a payment issue or course recommendation issue. I don't think so. Or yeah, then in the end we have this general one. So again, confidence score. So when it is not a technical, it is not a payment, it is not score. So it means that confidence score is 0.4. It's very low. So definitely it will automatically go to general, right? Now, uh, let me see. I think I did one more thing as I, explained you in the architectural diagram that I set the confidence threshold. See, this is the confidence threshold that I set. Okay, because I do not want to blindly trust whatever route the model picks for me. So I, set this confidence threshold, and if it is below 70%, like this one, if it is below 70%, okay, then I override the decision myself and send it to general support. So, you know, because I wanted to give it to the application to decide rather than giving entirely to the model to go after it. Then let's see some important stuff if I can show you. Uh, okay, one of the most important thing is to creating a router node. Uh, yeah, let's talk about nodes now. Let's talk about nodes. Creating a, I'm going to share you this complete Python file so that you can run from your side. And if you want to add some more agents, you can do that too. Now let's discuss this one. What is a router node? Now this one over here, uh, this grabs the latest message. Okay. Then it runs through the structured router LLM. Okay. Then applies the confidence threshold, like I showed you, the confidence threshold, and hands back to the final route. So let me show you an example. See what happens when this is applied. Okay. This is the state. You have message, route is done, confidence is done. But when this query runs, this one is run, the router node runs, okay, uh, it gets the confidence score and the route changes to billing. So from this to this. So the LangGraph applies those updates to the shared state. So this is a shared state. So the state changes from this to this. Okay, this to this. Like if I tell you over here, if you see this example. Okay, see router node and test state. This is what I mentioned, and this is it's calling the function, and route is billing, confidence is 0.95. Okay, okay. So that was router node. Now let me show you about creating the four specialized nodes. I'll also show you how these were created. Again, see, this you have understood, right? Technical gets troubleshooting instructions, course gets recommendation instructions, billing gets payment handling instructions, and general gets the other catch-all prompts. Okay, but the most important thing I want to show you is building nodes. Now, if you focus over here, almost this is similar to the router node, but there's one thing I've added. So first of all, this user message, okay, from this last message is grabbed, okay. Now this is the actual user query, okay. Second, it builds a two message list, okay. First is the system message, system message that tells the model that you are a technical support agent, help with buffering, login problems, okay, or website errors, okay, and give practical troubleshooting steps, okay, and then a human message. Now, this is just a user's query itself. Then third, LLM.invoke messages sends both of those to the model to get back an answer, okay, and this fourth one, messages response. This is what happens over here is that uh, like it returns messages response which LangGraph appends onto the shared state which I showed you. So the conversation now has a user's question and the specialist's answer in it, which will I'll show you in the Langsmith also. Okay, Langsmith also. Same goes for these course agent node. Okay, same way. Okay, but with different system prompts. Okay, this is the course agent node system prompt, course recommendation learning path, which goes to start, course pack prerequisites, then billing agent node. Okay, Then general support agent, unclear, ambiguous, general questions not clearly related to technical support, course advice. So almost same, but with different prompts. Okay, but with different prompts. Mm, okay. Now, let me talk about this conditional routing function. Now, this function, this route underscore query function is the bridge between router's router's decision and LangGraph itself. Okay, LangGraph itself. It just reads state root and returns the name of the node that should run this technical agent, course agent, billing agent. So if root is technical, then return this agent. If it is course, then return this agent. Okay, then return this agent. Right. Now, if you scroll down a bit more, I'll show you about the complete lang graph. Yeah, this one. This is the clear picture. Start, router, billing agent, then routers, course agent, general agent, technical agent. Now try to understand this particular graph. Now this state graph, let me show you. Now this state graph, okay. Now, this creates a graph using shared state schema. Okay. This add underscore node. This registers all five functions. The router plus the router plus these four specialists. These are nodes, which means these nodes. This is also a node. Okay. This is also a node. Then add underscore edge start router. Okay. Says that every run begins with the router. Every run begins at the router. Okay. And then we have conditional edges. And then we have conditional edges. Okay. What it does, it tells LangGraph to call root underscore query, to call this root underscore query after the router runs and branch dynamically based on what it returns. Okay. I hope you understand what I'm trying to say over here. Okay. And in the end, as I think I also show you in the that diagram, each specialist, each specialist has a fixed edge straight to the end. The same thing that was shown in the architecture. Okay, because architecture was much more explainable, but I wanted to show you how this was built. Okay, how this was built. And again, one last important thing, builder.compile. Okay, so what it does, it turns the graph definition into an actual runnable object. Okay, okay, let me show you now, like, let me show you something practical. Okay. Mm, let's try to run the queries live. And then I'll also show you the same thing in the Langsmith. Suppose this one, this is the function from here. Suppose uh, test technical question one. Suppose the video player keeps buffering. This is the first technical support question I'm asking the agent. Now see what it did. Query is video player keeps buffering. Selected route technical. Confidence score 0.95. So check its response. I'm sorry to hear that you are experiencing buffering issues with the video player. Here are some of the troubleshooting steps you can follow to resolve this problem. Now, this response is from the LLM after going through all the routes, you know, it also checked the system prompt, the user query, the confidence score, and the confidence score was calculated based on this. Okay, video player is keeps buffering, so I think it's right. The confidence score should be this much. Okay, send the request to technical and check the response. Okay, check your internet connection. Ensure that you have a stable internet connection. Ensure that you have a stable internet connection. You can do this by running a speed test. If your connection is so slow, try moving closer to your Wi-Fi router or connecting via Ethernet cable. Close unnecessary applications. Lower video quality. If the platform allows, try lowering the video quality. So it is giving you the troubleshooting steps or resolving your issue by asking you to do these following steps. Okay. So suppose a user enters a query. I have a problem with my video. The agent automatically gives this answer. Okay. No human involved so far. Now, another question. I'll run it live. I am unable to log into my account. Another technical question. Let's see what it does. Again, selected route, technical confidence score 0.95. I'm sorry to hear that you have a trouble logging into your account. Here are some troubleshooting steps. Check your credentials. The first very thing that comes to one's mind. Reset your password. Clear browser cache and cookies. Try a different browser or device. Okay, make sense? It should go to the technical support agent. Now, another question is related to, or another query is related to the course. I want to learn generative AI. Which course should I start with? Let's see. Now, selected route is course. Confidence score is 0.9. So see what kind of curriculum it gives. To start learning Gen AI, I recommend beginning with foundational course that covers the basic AI and machine learning. Okay, as these concepts are crucial for understanding the generative AI models. So let's take the curriculum. Foundation of AI and ML, course Introduction to AI, Basic of AI, Type of AI Applications, Machine Learning course, then dive into deep learning specialization, then some projects, work on personal projects or contribute. So it is, answering the question for a user who wants to learn Gen AI. Okay, so this agent is helping that person or helping that person or creating a curriculum for that particular person. Another query, which course should I take after completing the Python basic course? Let's see. So one by one, you know, you start with technical, you start with course, and you start with payment. You know, I was charged twice for the same course. Let's see what answer does it give. I'm sorry to hear that you have been charged twice for the same course. Here's what you can do next. Check your email. Look for confirmation email for both transactions. This will help you verify the charges and gather details for your inquiry. Review your payment method. Check your bank account or payment method. Contact support. Refund process. Once we receive your information, we will investigate the issue. So these are the kind of queries that human used to answer. Now LLM is answering based on certain rules that we have set. Based on certain rules that we have set. Okay. General query one, which I really wanted to show you. Uh, do you have a mobile app for learning? The confidence score is 0.7. Okay. Answer is thank you for your question. Could you please clarify what specific features or functionalities you're looking for in mobile app for learning? This will help me provide you with the most relevant information. So it is querying the user again because it hasn't got the answer what it is looking for, because general agent are going to answer general questions. So it is come making the user or asking the user come to the point. What agent should I route you with? Or if you really want to talk to someone, I can route your call over there. Okay. Then again, this I contact how can I contact customer support? Okay. So these are some category of questions, expected routes, which you can go through. Okay. Now let me show you important stuff, the Langsmith one. Okay. This is my intelligent customer query report. Now, the last question, the last query that human entered was this. So, do you have a mobile app for learning? Output was, thank you for your question. Could you please clarify? Okay. Then let me show you the important one, in which there was some proper queries. Okay, this one. I want to learn generative AI. Okay, which course should I start? Here's the output, which was in the Python file. Generative AI focus, advanced generative AI techniques, required skills, okay, career guidance. So it gave you everything. Step one, foundation. Step two, into deep learning, generative AI focus, advanced generative AI techniques, okay, then required skills. Now, the root is course, confidence score is 0.9, okay. This is a system prompt that we set for the technical router agent. Okay. You're an intelligent query routing assistant for an online education. Oh, sorry, this is system prompt. This is a system prompt. Technical use this, course use this, billing use this. Okay. Root query. Okay, root query, it is taking to the course agent. Let me show you the system prompt. Not the system prompt. Uh, this is the course agent output that was already there. Mm, yes, this is what I was looking for. The particular prompt for this agent. Like you are a course advisor for an online education platform. Help users with this course recommendations, learning paths, which course to start, course prerequisites, required skills, career learning guidance. Provide helpful and educational recommendation. Then user says, I want to learn Gen AI. Which course should I start with? Here's the output. To start with Gen AI, recommend beginning with foundational course that covers the basics of artificial intelligence, and machine learning, as these concepts are crucial for understanding generative AI. Is the requested learning path. So I have showed you results in both ways, in UI as well as in the Python files. Okay, LLM output 6 attributes and this. So we have both the prompts. We have system prompt. This is the system prompt. Okay, okay. This is the output. This is the root course confidence 0.90. Okay, and this is the user's query. So I have system prompt and the agent specific prompt also. Okay. So this is exactly why tracing matters for agentic systems. You can see the exact decision, the exact confidence score, and the exact prompt and produced it for every single request. Okay. So, so to to recap what we did today. See, we built a router agent. We built a router agent that reads customers query. Okay. Then uses a structured output LLM to classify into one of the four departments. Okay. Which were those? Technical, course recommender, payment, and general. Okay. Then we also applied confidence confidence threshold, which has to be if it is less than 0.70, then this goes to general. Otherwise, it goes to others if it is more than that. Okay. And uses a and we used a LangGraph conditional edge. Okay. To dispatch to the right specialist. To dispatch to the right specialist. Okay. Then all traced, all traced to, all traced, all traced information in Langsmith. Okay. So I would say that you should try by yourself. Okay. I'll share the codes with you. Fork it or clone it. Okay. Add four agents I have already added. Add any one of these fifth or a sixth agent by yourself. Okay. Run this file completely and add more agents into it. Okay. Uh, Without touching the router logic at all. Okay. Just add a node and a branch and start your work and see what happens. Okay. The full notebook and the readme with the architecture diagram. Okay. I'll share with you, which you will find in the description box below this video. Okay. That is on the GitHub. Okay. In the like this one was completely a Jupyter notebook. In the coming days, I'll build a complete, a modular coding project, you know, uh, or the files would be completely organized. Like, router agents will have each router agent will have their own file. Like a technical agent has its own file, or the other specialized agent has their own file. Won't be an experimentation kind of a stuff. But I think I have in my previous session, I have showed both the Jupyter Notebook and the modular coding of that particular project. You can watch that video. So yeah, that's it. I hope you like this video. You have learned something useful. I'll again ask you or require, pursue you to run the complete file with some notes in it, because in this particular session, in this kind of session, you can't explain everything. But once you run that, you will understand uh, whatever this agent does. So see you. In the meantime, uh, happy learning. See you soon with something new, um, maybe related to agents or something else. Okay. Okay, bye.